please, I'm sorry for any mistakes. Okay, so Webpack. Our Webpack starts around 2009, where I'm going to tell you a little bit of story of front-end world. I think it's quite important for to understand Webpack. I think it's quite important to understand the context from which it came and the ones that were before him. So, in 2009, these were the tools that we were actually using to use applications, to make applications. I'm not sure if anyone knows any of these. Probably no. Hmm? Why was awesome? Okay, but applications were starting to grow in size and complexity, mostly because of these frameworks. And people start to organize their application in modules. But first, it was not like module as a dependency, it was module as a concept of code inside the application. Most like organizing classes and all that stuff. Around 2009 was also the year that Node.js started. And Node.js kind of changed everything for the front end. It was not the first server-side implementation of JavaScript. In 95, Netscape actually tried to implement JavaScript as a server-side language. But it was the one that actually became popular. Okay, server.js. Remember that I was talking about modules? The guys at the backend that wanted to use JavaScript, they really required modules to be a separate file. So a guy in Mozilla started the group server.js. It was a community group where they were trying to establish standards for JavaScript, for any kind of JavaScript in browser and server, but they didn't have any implementation yet. Okay, bear with me, this is history. Server.js was later renamed to Common.js. Is this more familiar to most of you, probably? Okay. The point was to specify JavaScript outside the browser. And here was the major problem. Have you tried to standardize some kind of technology without an implementation? So just to put in context, 2009 was the year that Node.js appeared, but it was like November. This was happening in January. So there was no major implementation of JavaScript server-side, and yet they were trying to define modules for the server-side. On the front end, on the other hand, we had this. These are actually module loaders or bundlers available for any front-end developer that wanted to import dependencies asynchronously. Of all of these, two of them actually became more popular. Nice. This is in the wrong order. Great. Anyway, let me change this. Two bundlers became popular. One used the Common.js standard, this standard, and the other used the AMD standard. As most of you are probably aware, the first two lines of code, I'm not sure, can you see my mouse? Great. These first two lines of code require the module that we want to. And as probably most of you have noticed, if you are familiar with JavaScript, this is synchronous. If you notice, there are no callbacks here. You have to wait to load a module, then the next one, and then you can do your computations. On the other side, there was the AMD kind of module. It also started as Common.js, but this time is asynchronous. You define the files that you want to, any of them, either by name or relative for a file, and then you have a callback specifying, okay, now everything is loaded, I'm going to use them. This was asynchronous, and it was perfect for the browser. Okay, so require.js, the king of our configuration files, if anyone has used, is the loader that uses AMD. Everyone will start with the index HTML, and it just places a script tag on the bottom saying, hey, please require.js. It's kind of weird to say require. But require.js, and then start with the file specified data name. And this file would look something like this. A huge file with a configuration stating, hey, here's my vendor, I need mount, you can find it in this folder. Every time I ask for mount, give me that file. On the other hand, some files were not ready to be used as a module loader, as a loader, and then you have to teach require.js to require those files. For example, Backbone, it was a huge framework around 2010, 2011, requires underscore and jQuery. So before we require Backbone, we have to require those two first. So you have to tell it. And because it didn't know how to be a module, it would export its value to a global variable. And then we have to tell require.js, hey, you can find the result of this module in this variable. And so on and so forth. And this is what happens in the browser. Because you require a module that requires more modules, and then again requires more modules, you get a dependency tree like this. Obviously, this is not optimal, and later a new tool called RJS appeared to concatenate everything into one file, which is kind of weird. On the other hand, there was Browserify. Browserify took another approach. I'm not going to load your modules. I'm going to bundle your modules. It's different. When you load modules, you load them as you request them asynchronously. When you bundle your modules, you compute all the tree, everything you need, and then you just concatenate everything into one file. Browserify, the king of the IFI. I'm going to tell you why, just in case nobody knows. But this would be something else. This would be a common module in JavaScript with the Browserify. I'm going to show something really weird. Do you see everything? Do you see it on the top? People require dependencies, as I showed you before. That's pretty regular, pretty normal. Here is the weird stuff. I'm now assigning to a variable load my function require. And I'm going to use load here inside the require module. This is valid JavaScript. And this is problematic because Browserify can no longer just read every time you ask for require, grab the file with a WebJS or something. You can't do that because suddenly it's load, and suddenly there is an if, and I'm going to require, otherwise I'm going to load. This is just, you can just do everything in JavaScript. So Browserify implemented a new technique, technique that should work, called static analysis. It would read a JavaScript file. It would convert to an abstract syntax tree. An abstract syntax tree is when you represent our JavaScript file in here as a tree, as a JSON file, for example, if you wish, where you represent our program, which has a body with 4 variable declarations. If you notice, there are 4 variable declarations here. And then an if statement, and so forth, so on, where the point you are actually interpreting the code. Because you are actually interpreting, you can actually find every dependency around the code. This is kind of complex, but it was new at the time, and it's going to be quite useful for us later. And this is the reason why Browserify is called the king of the IFI. If you wish to load a JavaScript React file, you need to parse that file that is not JavaScript into JavaScript. So you tell Browserify when you request this file, please give it to Sweetify, which is a package that do some transformations to the file, and then please pass the result to Babelify, which would convert the React stuff into JavaScript stuff, and then to a JavaScript file. 90% of plugins for Browserify are called something ify. Everything. There is Sweetify, Babelify, Macroify, everything. Okay, but the point taken is the abstract syntax tree. And this is the point of our timelines with modules. There was CommonJS in 2009, AMD 2010, CommonJS 2.0 in around 2013, doesn't really matter. And Harmony in ECMAScript 6 and ECMAScript 2015, whatever you want to call it, in 2014. The Harmony stuff is what you are going to use. And it was pretty cool because do you see all those standards that already exist to load modules? Yeah, nobody cares about them. Let's start all over new again. But this new standard was made with something in mind, to be static analyzed. So the whole point of the new syntax is so you can be certain of which models you are requiring and what are you requiring from each models, which functions, which objects. Okay, so our story kind of starts here. There was Record.js, Browserify, which they love each other very much, and then they have Webpack. But the problem is that they were drunk. Trust me, they were drunk. So Webpack, the current king of configuration files, because it's even worse than Record.js. Here's a very simple configuration for Webpack. It's mostly divided into 4 parts. There are more, but 80% of the stuff you want to do can be done in these 4 parts. The entry file, every file that you wish to be the center point of the beginning of your application. Where to output your files, which name you want to give it, if you want to add a revision number, and folder. Plugins. Plugins work around the entire project. So before starting to parse our project or after you've parsed our project, the plugins will work around everything in the tree. And finally, the module and loaders section. This is kind of equivalent to the Sweetify and Bubblyify that was shown in Browserify. Every time you read a file, if that file matches this test, which is usually a regular expression, please pass that file to this loader, which will transform and give us the result. So, if you want to do something like this, have an entry file that actually requires 2 files and output a single file. Everything we need is the entry specifying this file and the output, which is going to result in the latest file. But here's a catch. If one of our JavaScript files actually requires a CSS file, and this is something new, we are treating CSS as a JavaScript dependency. This is quite different from Browserify in Record.js. We can tell it to, every time it finds a CSS file, to convert to CSS and then to pass to a style tag. No biggie, something simple. Now here's something different. For every entry file that you have an output file. This match is always 1 for 1. But we can use a plugin to parse our tree after it has been compiled and extract all the CSS into an output file. This is what we are doing here. We are using a plugin that is going to generate a file called style CSS. And here with the loader, we just do some dark magic to extract the file. No biggie, but kind of weird. Then that's just, okay. So major features from Webpack. It accepts CommonJS, AMD, Harmony modules, you name it. If there is a module, you accept it. You start to treat CSS and images and JSON files and XML files and templates as a JavaScript dependency. You can import all of them. You just have to teach them how to handle them. It's a loader and a bundler. So the Require.js was a loader, Browserify was a bundler. The Webpack is both. They can do both at the same time. Web Dev Server, it is just for convenience. Instead of always compiling, it will bring just, okay, here's our server, every time you change a file, I'm just going to compile that file. Code splitting and loading on demand, this is the best part. And tree shaking, not module replacement. Tree shaking is the reason why Harmony modules were made from static analysis. Tree shaking is when you require one function from a module, and all you are going to get in the final output is that function, not the module, just the function. And hot module replacement is what feature really weird. I'm not going to explain to it because it's really, really weird. Okay, so at this point I have to ask you, do you guys want a demo or not? Because seriously, it's going to be fun. Not a demo, it's going to be fun for me to explain all of this. Not for you, it's going to be bored. Okay, so I'm going to need my stuff, which is around here. Now, here's the problem. This is not my computer. Most stuff is probably not installed or stuff, but okay. Okay, before doing the demo, does anyone has questions or stuff that would like to see? Because as you can see, this is very introductory, it's very basic. And I know people are working with Webpack right now. If you have questions, now would be a good time. Seriously. Any projects, stuff you'd like to see? No?
Absolutely. Imagine that you have, you are, like you say, you are extracting the CSS file,
Yes.
and you want to inject them in a template or something,
Okay.
and you want to index them. You have some options there to put, to insert them on body and head or somewhere. I want to inject them where I want and not just inside the body.
Yeah.
That's something that you can do.
I'm assuming that you are using a HTML plugin, probably. That's why you have that option.
Yeah.
Okay.
And now I'm using Novas Builder just to configure some options.
Okay.
So I have the Novas index, and Novas templates. And I want to inject CSS and JavaScript in a certain, not somewhere in the body.
Okay, so I'm going to work the rest until there. I'm going to show some stuff to people until we get there.
Yeah, cool.
Because as you can see, I have some folders. One is CSS styles, and the other around, I think, is a plugins as the HTML stuff. So, okay. Does this work? It does. Great. Okay. npm install is going to install. While it installs stuff, I'm going to show. Yeah. This is a more complex JavaScript file. As you can, he's talking about injecting. Okay, first things. We are using the plugin to extract CSS. You probably can see much there. Is it better? So, new extract plugin is going to collect all the JavaScript, all the CSS that it found, and extract to a file. And is also using the Webpack, the HTML Webpack plugin. I need to explain what this plugin does. The only entry that I have actually is template and source index. If I go to your source index, you are going to see just an HTML5 with the idea. There's nothing else. But that plugin is going to pick up this file and get all the files from JavaScript and all the files from CSS, and is going to inject them here with something like this. And it would be something like main.js, and in here it probably will something like this, styles.css. So that's what the plugin does. It collects all JavaScript, places a script tag here, and the CSS tag there. What you're asking is to have something like this in here. You can do that. It's not that easy. Okay. This is really a really specific question, but this plugin accepts templates, and it has AGS templates if I recall. So I think you're gonna have something like this. I'm speaking from memory, where you have an object, that actually has all the stats, all the information that Webpack made during the compilation step. Correct? You can access that object. It's going to be easier this way.
Yeah. I know we have the options that we send to the internal Webpack. Why connect it with the Python or something like that?
Yeah, but
I don't know if you have access to it.
We do.
Good. Can you have the display on the program from the side? Because I think people are not seeing the display. It's input plus sign, input display capture. It's the, yes? Yeah, it's this. Yeah, okay.
Nice.
Okay.
Should this be okay?
I think you have to click it okay in the areas. Okay, yeah. Okay.
Yeah. Do you see this part here, the options title? I'm pretty sure that you have access to an object something like this. Okay, so Webpack file the message.
Oh yeah, definitely.
Yeah, the following verbs are available in the templates. So you have access to this. You get actually, this is what we are using in TVG Grid. We are getting an object like this with every information from Webpack, and then injecting all these resources information in your file and just go.
So if we have like hash versions of ours,
You see, they all be in here in the same output. Instead of main CSS, you're going to get main dot whatever dot CSS. Okay, exactly. So I'm going back to get out of this here. Take this out. Anyway, I want to do this. Thank you. Okay. I'm going to do yarn build that react. Yep.
I think I do.
I'm just so used to yarn, sorry. I'm an Ipsy. Okay, so this is a small project which I'm going to show you. And this is most of our configuration. At this point, you can see that I'm already doing some weird stuff here. I have a main file that represents our main entry point. In our main entry point, there is like an importation of CSS, render, all that stuff. And then Webpack config. I have a second entry just stating React, React Comment, React Router. This is our dependencies, and I'm trying to split them into a separate file. Remember what I said, one entry point, one output file, 2 entry points, 2 output files. That's pretty simple. But then I have to use the comment chunk plugin. Here's the deal. If I have 2 files in the entry, it's going to do 2 bundles. But if my first file requires React, I'm going to have React in both files. It's going to be duplicated. When I say comment chunk plugin, when I use the comment chunk plugin and I state, hey, there's the vendors here, use the vendors here, and the min chunks is infinity, something like, I don't care how much time it's there, you're going to split it to a file. Then even if the main requires React, the React is not going to be bundled in there, it's going to be in a separate file. I'm going to show you this right now, which I'm assuming I can do something like this. There. This is not the most awesome demo, but if it works correctly, I should have 2 files here. There. Here's our vendors, here's our main. As you can see, our main has 179 bytes, something really small. But our vendors have like, 181. Nice. I can remember this. I'm doing a few more stuff in here I'm going to show you. If I go to main.js, and if I go to my routes file, my routes file have something not usually seen in React. Instead of just stating, here's a head, here's a path, here's a component, I'm saying, here's a path, and now get the component from the sync function. So every time that I go to the dash, to this path, he's going to load this asynchronously. If I go to about, he's going to import about asynchronously. I think we can watch this happening here. If I dock it, sorry, if I dock this in here, I'm going to play this. I'm going to click about. As you can see, it will actually load the JavaScript file. This is all, okay, like I said, it's not the biggest demo ever. But the point is, I'm loading everything asynchronously. Our bundle was really small at the beginning, and we load stuff as we go. This works with everything, really. But with React, it's particularly easy. That's why it's fun. There's also another fun stuff. Remember when I told you that auth module replacement is something really cool? that usually works really well with React because of its architecture. Because we have, I'm going to talk about, okay, React hot module replacement, something like this. Every time I come to our file, and I'm going to change a component, for example, our root file, and I'm going to say, boya, I'm going to save. And did you see here update later recompiling, reloading? It would happen the same thing. Instead of reloading, it will get just the changes that it actually occurred. So that component will change. It's going to receive only that component, and then it's going to our application, remove the old component, and paste the new one. Only without refreshing. And this is particularly cool because most people with React also use widgets, which places all the store into a global object outside of the React component. So if you reload the component, but the store remains the same, then every component is already placed with all the new information. If you are developing a form and you already filled like 5 fields of the form, it's not going to erase all those fields. You're going to get the form is going to be still written. But it's really hard to get that right, actually, even with Webpack.
I have a question.
Yeah.
You are importing these styles here, but you have the extract plugin in the Webpack view. This extract will extract all the CSS for each component and you will put in the end, right? But you are saying that you are putting chunks of code in the every time you click on the address. This CSS is also injected, or you have only one CSS?
Okay. In this demo, we only have one CSS. We have only one CSS because I'm building all chunks true. So it's going to find even the async imports. It's going to find them, get the CSS from there, and extract it in one single file. However, if I just go here and say false, then it's only going to extract the main CSS from the root file. Let's see if I can get something running here. I have to start all over again because of change of configuration. And I need to disable cache. Okay. I'm trying to come here to the home. Okay. Okay, come. One main CSS file, and as I go to here to get home, you only see a JavaScript file, but I'm pretty sure it's going to be around here with the style tag. So instead of loading all the CSS in the first load, you kind of split them and then inject them into CSS style tags. Didn't everyone understood what I said? It's kind of weird.
Can you just go back to the code? You are saying that you're running the styles, not the main styles, CSS with the styles inside of it.
Okay, so I'm importing the style here. And then each component imports their own style if they have them. I think artist has. Nope. Come on, this one. Okay, and then as you can see, I'm importing styles for each component. This style CSS only has the CSS from this module.
So basically we are just putting all the CSS and the JavaScript and we get to load the CSS.
Exactly. When you load the JavaScript, it also loads only that CSS.
But we can do this with the same, we can do this extracting CSS files also.
I never actually tried to extract this also into a CSS file, to be honest. I'm not sure if it would be cool. I'm going to, because of this. If you extract it into an extra CSS file, you have to load the JavaScript file, which will then reference the CSS file. So we're going to have two requests. And they are going to cascade first. The JavaScript first, CSS later. With this approach, everything comes with the same JavaScript file, but then is automatically loaded in this file. I think for the sync stuff, this is better. I think. I'm not entirely sure, to be honest.
But when you, that was my question, when you change the tag, you will not inject the same styles again,
No,
because
only-
it's already injected.
Yeah, only the new one. If I go to about, Then to add just going to be,
Okay.
I already load. If I go back to home, it's not going to load
It's
anything.
not exactly the CSS.
That's it. Yeah. What else can I show you? Okay. Like I said, there is another, as you probably saw so far, there is a dev server here that Webpack supports. Okay? This dev server is what actually allows us to do something really neat. You probably have seen so far, but sorry. Again, not my computer, this is hard. Come here. Is this okay? I think this is okay.
Let's spec it.
Hmm?
Let's spec it.
Yes, there is. Great. So if I can. I really advise everyone to use this just because it's faster when it works. Compiler capacity 3. And then I have Boya. The tree shaking. What else about this? I'm sorry, I'm not afraid of this here. Since I stopped my linear flow of explaining stuff, I can go back if you want to.
You can explain now how you can load the lazy loading of JavaScript instead of. I know that you have a problem of Mindera that you only have one file for everything. You have one bundle.js for everything, and it takes time to wrap it up all things for manual. And I think you build lazy loading stuff to inject the JavaScript on the fly.
You're talking about what we do on TVG or something?
Yeah.
What we do in TVG is we kind of do that. How can I explain? That's kind of a lot of different. I think I'll talk about it with you later because it's not even Webpack for that. It's mostly because when it comes to code splitting, most of the magic comes only from the JavaScript syntax, where we just do what we do. Here are my routes. To load asynchronously, all you have to do is this. Everything. You just tell import my file, and when the file is ready, just load it. What we are doing in TVG is quite different. We don't load this asynchronously at the moment. We kind of bundle them in parallel, which is a lot different. Okay, then code splitting, common chunks. Something a little easier for now. Images is something pretty cool. Are you guys familiar with Fibonacci and all that stuff? Fibonacci, factorial, you guys know the sequences? Great, because I'm going to talk about them. In this part I'm importing a Fibonacci function, and I'm importing its numbers in here. If I show you the numbers, I'm importing images directly from JavaScript code. And then I'm going to use these variables, which are storing the file, to make a small application that pretty much does this. Yeah, not a really exciting. But here's the trick. It kind of changes, right? Please tell me it changes. 54, 10, 55. And later on, you can do this just with a simple loader with PHP. Which stands for PNG files, use the file loader. The file loader will return the URL, the final URL of that image, which I kind of need here, as you can probably see. This is the simple return of it. But most of you know that most of our images are quite small. They don't really justify an extra request to get them. So we have the URL loader. The URL loader does the same thing, pretty much. But I'm saying just this. Every time you find a PNG file, use the URL loader. but if the file is bigger than 7 kilobytes, just get me the file instead of the base 64. The URL loader just converts them to base 64. That's just it. So if I just in here, it should actually be faster this way. Not this one. No, damn it. Did I close the window? No, I think I did. Okay. So you get here the first image, it comes as a PNG file, but the second one, which is not bigger than 7K, comes as a base 64. This will allow us to optimize the balance between requests and file size. Okay.
That's really low, which is it's 7 kilobytes.
Yeah, that's the limit.
Okay.
If the bigger is, here's the point. Every time you load something in base 64, it's approximately 30% bigger than the original size. So you kind of have to make it the balance, because if something weighs 10K, it's going to weigh 13K in base 64, which kind of starts to be a lot. So this is pretty much the balance. You can just say, if it's bigger than 7K, use the file loader. I prefer the extra request. Okay, I'm going to do the final demo, which is plugins, which is something that comes awesomely nice. So here, and here I go again. Plugins allow us to do a lot of things, and one of the things that progressive web apps do now is that they cache on the client side most of the resources they use. For that, they have to keep a manifest file, load their app caches, and all that stuff. Well, not that, okay. Okay, so in the plugins section, I get to do something. Please erase the dist folder every time I do a bundle. So every bundle generates files. This cleans the folder. I'm using the HTML Webpack plugin that we talked about. And I'm using the offline plugin. The offline plugin works together with a small library that allows us to do a hard cache of our resources. That used to probably sound no difference at all. But here's the, hey, come here, and don't do this. I can read the cache here. And if I turn off my server now, here's the cool part, it still works. Just because I add a plugin. We can do this for everything in our interfaces. And then if we just want to deploy in the server, we just do a new bundle. That would be okay. And all I requested was only to enable a plugin. Yeah, I think I finished my talk. It was not good. It's kind of boring, but here's the problem with Webpack. It's configuration. It's really hard to make this really interesting because, hey, change this configuration. Hey, here's your result. It's kind of hard. So, questions? Anyone? No?
I have a question about the comment. That was pretty cool. Thank you for sharing.
Thanks.
Yeah, pretty cool.
Anything else?
Well, on Webpack, how do you say a folder that you want to add all these contents to the disk but not be processed?
So you want to pass resources to the dist folder, but not being processed?
Yes.
You'll have to use a plugin for that, which will just copy the results. It will be something like the copy Webpack plugin. I don't have the plugin here, but it will, from memory, it will be something like this: copy Webpack plugin. Yeah, it will be something like from to.
I'm just remembering to define the environment. I think it can define version or something like that.
Webpack itself comes with a bunch of plugins. One of them is the provide plugin. It's the define plugin where you can do something like this, node-env, which is usually a variable to tell which environment node is running. If it's running in production, then it will turn off the debug statements and all that stuff. And you do something like JSON stringify. And then here, because it's a nodes process, I can just do this. You can probably ask yourselves, why the JSON stringify? But the thing is, it's going to copy the result and inject in our code, literally, anytime we do something like a equal to node-env. Webpack is going to find this string and literally replaces with production. This is pretty cool to define environments. But usually in our apps, when we want something like, we use the node environment. Okay, personally in TVG, we use the node-env to define if a bundle is optimized or not. So if we set node-env to production, React is not going to do a lot of verifications. But we don't say that the product is in QA staging or production with this variable. For that, we use the environment variable, something like this. And it would be something like QA, for example. The point that we don't use the node-env is because when you define a variable at compile time, we can no longer change it in runtime. And we need to change our configurations at runtime. We do this build once, and then the same build goes to QA staging in production. But it has to load different configurations from QA, from staging. So we can't hard code this environment variable. So we only hard code the node-env and not this one. I'm not sure if I answered your question. Go ahead.
I noticed that only the node environment passes through the JavaScript environment. When I'm using, for example, React, I do the MTalk of the environment only node
Is there
any other variables that you can add?
I'm not sure how's your project, but in our configuration file in Webpack, this is Node.js. It's run by Node.js. So you can access all environment variables in the processing object.
For example, on the main.js, I only have access to the node.
Yeah, that's okay. The processing in Node.js, all environment variables are available here. So we can do this. That's cool. We can get them in the main.js. But now I can do this. Home, JSON stringify, all the same, and just keep injecting them. I will have the home available here, and it's going to be copied to the main. I never tried to pass the entire object, but I think you can probably do something like this. Process env equals, hey, come on, JSON stringify, process env. I'm not sure, but I think if you do this, you'll have all the available variables. All the variables that were available at compile time in your client side.
And those will be uploaded to JSON.
Yeah.
Yeah, but it's still the big because it will replace all the variables.
No, there is actually a problem because it's going to put everything, all these variables in your code.
Yeah.
That's probably not a good idea. But you can specify each variable that you wish to. I think there is a newer plugin just for this, which is called the environment plugin. I've never used it. I've just heard about it. But with this, all I think you have to do is something like, I want this variable and I want this variable. That is, for this case, just shorter syntax. Okay. Anything else? Please ask for questions later or something if you want to.
Podes fechar aqui. Stop streaming.
Sim.